In this video I am going to show you how to make use of Modbus function number 6, which is how to write a single value, writing a single value in a holding register. That's what the purpose of function number 6 is. As I've said before, in our case, in the case of our GA project, we're going to measure two values. In our case it's going to be temperature, the other one will be a water level. But you want your slave microcontroller to react on certain settings values. So this is what the purpose of a holding register is. You place value in the settings register. Like if the temperature goes above 80 degrees Celsius, something should happen. If the water goes below, let's say 1,200 liters or whatever, something else should happen. And this is why I'm going to show you how to make use of function number 6. Now, as I've said, also a holding register, you do not want a holding register value to disappear when the microcontroller or microcontrollers shut down. And this is why we will rather put these values, the holding registers, in EEPROM memory. You will see in my program what I've done here is I have created a holding registers, holding reg, and I've created 5. I know we're only going to make use of 2, but we've got the space, so we don't care about that. And you can see here that I have placed this in EE memory. So you specifically allocate this thing and say, put this in EE memory. And it's also, it will be 5, in this case here 5, integers, which will be placed into EEPROM memory. If you look at something like whatever it says here, integers and whatever the name is, doesn't matter what the name is, but this will be placed in normal RAM. So this is placed in EEPROM. Okay, so I've still got exactly the same diagram as you can see here, and I am going to place from basically tell my master will tell the master microcontroller will tell the slave microcontroller to store a certain value in it. Let me go to the program. Now normally, I mean, it's just logic that there's my while one loop. I would definitely, in a case like this, always do this outside the while one loop. Otherwise, you're going to keep on writing data to the EEPROM, and if you write data to the EEPROM, you're going to damage them within a few minutes. It can be damaged, or even seconds. So we will always do Modbus function number 6 and do that as a single writing. You can do it in the main program. Of course you can do it there, but you must be very careful not to damage the micro or the EEPROM. So in this specific case, what I've done here is I've written a function where the first argument will be the address, and in this case we are always writing to slave number 2 in my examples. And I am saying here I want to write to address 401. That is also the first address. If I can just recap, if you can remember, I've shown you that we will start at 4 something, and in our case we're going to say the first address is 401, the second one is 402, and so forth. That's the holding registers, and it is possible to write to them. This is function number 6, and the next one is also, which I will also do as a separate video, which will be able to read from them. Good, so let's go back to the program. In this specific case, I have said I want to write to address number 401. As you can recall, if I want to send it from the master microcontroller, you will have to make use of an address of 400. So what I want to send there is a value of 82. Well, it's actually 82, which is the same as hex 0052. You can imagine that this is maybe the temperature. I want if the temperature goes above 82 degrees Celsius, I want to store that 82 as a settings value inside a holding register of one of my slaves. So if I can go to the function itself, here it is. So the first one, as I've said, that the argument will be receiving the slave address, which is 2. The address there was 401, and the new setting in this specific case was a value of 82 decimal or 52 hex. So again, first thing I've done here is just subtracted 1, because we need, once we send it, it must be 1 less than the one I want to write to, of course. No? So that will, if I've given this a value of 401, this will change to 400, whatever, I think 400, yes, if I recall correctly, a value of, a decimal value of 400 is equal to 190 in hex, 190 in hex. So what will happen is, again, we will place in this function, or in this array, this is the transmitting array from my master, we'll place the address, the one I want to talk to, which is address number 2, function number 6. As you can see here, I've basically just taken, because the address, as you've seen, is 0190, so basically in position number 2 you will place a value of 01. So address just moved 8 positions to the right. We'll place 01 into element number 2 of this array. If I just place address there, it will just take the lower byte, which is 90, which will be placed in element number 3. And the new setting, as you've seen, I gave that as a value originally of 0052. So in other words, again, 00 will be placed in element number 4, and in element number 5 is the low value, which will be 52, which will actually be placed in element number 5. This will then be transmitted using that UR_send function to the slave microcontroller. On the slave microcontroller, I just want to see what the time is. Okay, it's 6 minutes. On the slave microcontroller, if we can now go to, we know, of course, that as data comes in, it will be received on the slave microcontroller, and it will come in. We've discussed this before. The first one that will come in is element is number 2. So this specific microcontroller will react, but it can only react after it has received 6 different bytes. 6 bytes will be sent by the master microcontroller to the slave, and only once those 6 are actually filled in the slave microcontroller will this thing react. Yes, it will be definitely slave number 2, and then it will, we've seen before how it will react on function number 15, and we've seen function number 1 also. Function number 2 we've also seen, so it will actually react on this one, function number 6, because that was the one that the master actually sent through. So the receive counter on this slave microcontroller will be at 6 at that specific point, and element number 1 will have a value of 06 in it, so then it will go into this specific function. And just like before, the input address, you can get that from element 2 and element 3, and in this specific case the input address will be, if we remember correctly now, we received 400 decimal or 190 hex. So we just increment that by 1, so now we're actually sitting at a value of 401 or 191 hex, 401 in decimal, of course. And the new setting, I'm again just combining element number 4, which was sent as 00, and element 5, which was sent as hex 52, combining them. And here again I've declared a pointer, and here I am loading, but now you must look at this very carefully. As you can see, I am loading the pointer with a value, or sorry, the address of, remember we've declared holding reg, and we are loading the input address. And what is the input address at this stage? It's a value of 401, because it's been incremented at this stage. Yeah, it was incremented. So that value inside there will thus be 0. So in this pointer register, it will sit with the address of holding register, sorry, element number 0, which is element number 0 refers to a holding register 401. But if I, for instance, if I've sent here a value of, let's say 404, for instance, or let's say 404, it would have been incremented to 405, and it would have been 405 here minus 401, which is 4. So element number 4 will actually, of this holding registers, will contain address 405. It will actually point to that specific address. So this one I've slightly changed it compared to some of the others, because in the holding registers I want to write at least 2 values. I need to write a temperature value, and I need to write a water level value also. So we've done in examples, we've done EEPROM data write, and this is just another version of that. The data was actually it's actually a byte write. It was called EEPROM write byte, and this is called EEPROM write word. So this will write a whole word. So you need here, as the argument for this specific function, you need an address. But now you can see the address, in this specific case, the address for the address of 401 is actually now given here, and the new setting is hex 0052. So I'm referring to the correct position, which is address 401, and the new value I want to write is 0052 hex. So this is just another function that you can also read the value, and again it needs the address. You'll see at this stage I'm not using the splat. I'm not using the splat because inside HR is the address, and this specific functions needs the address, and that is the address inside this HR variable. The same here, that's also the address of that variable. So I'm just putting the value here, I'm just reading it back. So here I've written it, so it'll automatically write the correct value into address 401, and here we will read it back. So what I'm doing is I'm just basically displaying on port B. I'm displaying it on port B. I'm again resetting the receive counter, and I'm just displaying this for a short while before I go to this function where I again start to transmit the data back to the master microcontroller. Again, this is the slave microcontroller. So it will send back, and it will say it's coming from slave number 2, slave micro number 2. It's function number 6. It will give the address, and again the address that you transmit back is one less than what is the original address. So 190 is actually 400 in decimal. And yeah, in this specific case, the high value of this new setting, I actually slightly need to change this, because this is perfect. This works perfectly for if the value sits in the can fit into a single byte, then it's not a problem. Like for instance, if it's 82 or 82 decimal, it's not a problem. It will send back the correct the correct value. So I'm going to make a slight change in this program for the next video, and then just show you. I'll come back to this one and just show you where it's changed. Good. So again, I will then transmit these 6 bytes to my master microcontroller, and I will then at the end on my slave microcontroller just show it was function number 6, and I will just clear the array of values that was received. So what I'm going to do now, I'm going to stop here. This is already a 14-minute video, and then I'm going to carry on with a video number 2 to explain Modbus function number 6 a little bit more in detail. Not more detail, but a little bit more information on the same function. Thank you.